Herbicides are chemicals that are applied to plants and used to kill the plants that they're applied to. When they function very well. If something goes wrong with them, they become a people pressure disease. If you spray herbicide on the wrong plant, you're killing the wrong plant. It's a people pressure disease. If you spray it on the right plant, then it's a herbicide. When we deal with herbicides, we do have sometimes problems of misapplication. You might misread the label, you apply it to something where it shouldn't be, you apply a little too much, you apply it in the wrong manner, you add something to it. These are all different ways that we could have misapplication. We have drift. When you apply any type of pesticide, the wind velocity around you should be close to zero. If you can feel a breeze, it is too windy to put that material down. You should not be applying it when you can feel even a gentle breeze. Think about this. When you walk at approximately 5 miles an hour, but you don't feel the wind. So therefore, if you feel wind on you, even a gentle breeze, it means that is at a velocity of greater than 5 miles an hour. Any particles that you drop down could be picked up by that wind and taken elsewhere, and we call that drift. There is movement in the water. Some of these materials get into the soil, they stay in the soil. Some of these materials are very soluble and can be picked up and moved in water. Therefore, it is a problem. Even if it's only found in the soil, if you have soil erosion, this can move herbicide. We've got persistence in the soil. Some of these things can stay in the soil for years. We have to look at the concepts behind this. Let's look at misapplication. These are symptoms caused by chemicals. This is epinasty of sugar beet caused by the herbicide pechloram. Pechloram is a indole type material, so it will give you an epinastic movement. That's one of the ways it kills the plant. You can see this plant is not doing very well. You got too close to the sugar beets, and that is misapplication. You can see this. This is phytotoxicity. The phytotoxicity in this particular case comes from a fungicide spilled on a turf grass. You had too much of it. It was mixed with the wrong materials. It just creates an osmotic potential that burns the material. Therefore, this is a misapplication. We've got damage from herbicide drift due to paraquat on beans. Paraquat is a very interesting material. You spray it on, and within 10 minutes it does this to the plant. You can almost watch the plant as it changes color from a clear color to a brown like this, and all those spots are dead. That particular part is not coming back. Paraquat is very problematic. We use it on fence rows. If you get a little bit off target, you're going to get it on the plants. It's going to cause a misapplication such as this. This is damage from herbicide due to misapplication of glyphosate on lettuce. Glyphosate is a material that kills a lot of different things. If you aren't careful on the application, you're going to hit off target. When you do that, you're going to get a burn or a damage of that particular material. This is on grape. You can see that they've got misapplication of a herbicide. This causes this particular symptomology. One of the things you want to see on this, and the way you can diagnose this as herbicide damage, is you really do not see a margin around the lesion. When you look at this lesion, you get a very abrupt change in color from green to the brown. That is often associated with herbicide, where you don't get a variation in color, a gentle transition. The other thing is you can see that it goes over the veins, and that makes it very distinctive in there. When we talk about non-target organisms, we often talk about trees. We talk about the drip zone. The question is, how far out from the trunk of the tree do the roots extend? You shouldn't apply any of these chemicals in the drip zone. They could easily be picked up by the plant roots. Normally, a good rule of thumb is you take about how tall the tree is. That's the distance you want to stay away from the trunk. If it's 40 feet tall, you want to stay 40 feet away from the trunk. You may say, wait a second, that's an awful long distance. Yes, it is, but if you look at how far out roots actually go, you would be absolutely amazed. This is what we're looking at. When they talk about the drip zone, what they're talking about is the outer part of the plant where when rainwater falls on the plant, that's the farthest out that it will actually drip off of the leaves. You definitely want to stay out of the drip zone. Some people say you take the higher diameter of the plant, you go that far away, but sometimes the roots actually go way out farther than that. A lot of times, the absorptive roots will not be within the drip zone, they will actually be outside of the drip zone. If we take this tree, this is a magnificent live oak tree. You can see how it's got all this neat Spanish moss in it. It's going all over the place. If we look at the edge of the drip zone, we're out about over here. It's absolutely massive. You don't want to spray herbicide within this area because it could get in on the roots. You probably want to stay another 20 or 30 feet outside of that. That is where you're going to find a lot of absorptive roots that could pick up the material. We also talk about persistence. Persistence is the length of time that the active ingredient is still functional in the environment. Persistence is going to vary from pesticide to pesticide, depending on a lot of different factors. We often talk about half-life. Half-life is one of the ways we look at it. Half-life is the amount of time required for half of the applied material to be removed. If you think about taking an antibiotic, they tell you you have to take it every so many hours because your body is excreting it. Same way with materials that you apply on plants. There are microorganisms in the soil that break them down. They may be reactive with sunlight. They may be unstable. Half-life becomes very important. This graph looks at half-life. At application, you have 100%. Time unit 1 after that, you have got 50%. Time unit 2, you're down to 25. 3, you're down to 12.5. 4, you're down to 6.5. You can see how in the beginning it started to go up very quickly. Then it starts to slow down and it becomes what we call asymptotic. The question is, how much of this do you still need for it to be functional? Half-life could be as short as a few minutes, as you would get with some insecticides in direct sunlight. It could be as long as a few centuries if you're talking about a material that is applied under the foundation of a house. Well, half-life varies depending on the product. What you see is the amount of decrease you get after every half-life span. This isn't really a herbicide, but I'm putting it in on this part because it comes down to the same sort of thing. This is de-icing salt. When you get up into the northern climates, they get all this massive snow. One of the things they do, if the temperature is not going to get too cold, which means it's not going to go down below about 20, 22 degrees Fahrenheit, is they will apply de-icing salt, which basically will lower the melting point of the snow or ice down to below that 20 degrees, so the stuff actually melts. When it melts, it can run off. The problem you get is sometimes it's a lot of salt that they put down. When they put it down, it can accumulate in the soil near the curb of the street. That becomes osmotically too much for the turf grass there to handle. You get this problem with death due to de-icing salt. In the springtime, you get a lot of rain coming in. The rain solubilizes the salt, washes it downwards, and gets rid of this particular problem. De-icing salt is one of the very interesting things that we talk about when we're dealing with a plant damage like this, much like you would get with the herbicide. In here, persistence is not that long because it's readily leached out. Half-life is dependent upon the amount of water that's actually being put in. These are very interesting to understand when we are dealing with misapplication of herbicide type materials that are going to target plants.